Hi, this short video shows the benefits of using ConTest for your microprocessor and FPGA developments. All too often, developers are familiar with their embedded systems and are comfortable writing programs for them, but when it comes to testing and debugging, could really use a simple way to see what is going on in the code or control different modes of operation. Sometimes there is no quick and easy way to write a PC GUI to help out. This is where ConTest comes in. All the hard work has been done for you and a custom setup can be created in a matter of minutes. All you need to control your application or just monitor internal parameters is a couple of spare pins connected to a serial port and a standard USB serial cable connected to any Windows PC or laptop. For this demonstration I'll be using a standard development board. This one is from Nordic Semiconductor and is running one of their devices containing an ARM processor, but this is not very important. All you need is something capable of generating standard serial port. The USB connector on the left is just there to provide power for the board. As you can see, the board is connected to an RS-232 to USB serial adapter lead. I'm using a small interface board to generate the RS-232 levels from the board's logic level outputs. You can do the same or use a lead which takes logic level signals directly. There are quite a few on the market available that can do this. When you plug the lead in, Windows normally will recognize it immediately and give it a COM port number. I'm assuming you have your serial port connected and ready to go. As a minimum, all we need is a couple of pins, TX and RX, and no software flow control. You can add extra control pins if you want, but most of the time just TX and RX and a ground connection will do. I have ConTest running here on the right hand side of the screen. This is how it looks when first run. The first thing we need to know is that the serial port is not set up yet, so we need to match the serial port settings up here with what you've got on your board. As I go up the available settings, you'll notice that the light on the left hand side turns green. This indicates that Windows has recognized that there is a device on that COM port. The one we'll be using is COM6. The baud rate I'm using has been set to 115200 with no parity, 8 data bits and 1 stop bit. So there we have it. That's set up. ConTest will remember these settings the next time you come in, so you don't have to do it each time. We're now ready to go, and we can use ConTest just like a standard terminal program. Any serial output from your program appears in the messages window at the bottom. Just press start to get going. The red and blue indicators above the switch let you know when the messages are received. When I press the button on my board, we should see a message and the blue indicator will light. ConTest is now acting like any serial terminal program, showing the messages in the bottom pane. You can continue to use it like this, and any messages it doesn't recognize as commands will be displayed here. With ConTest though, we can do so much more. By sending messages it does recognize, using a very simple format with fixed prefix, we can put controls and a lot more on the screen directly from the target board's code. When I press the button again, some formatted messages are sent. Here I have resized the screen, put a title on the top and added some indicator lights to show the state of some internal functions. If I press the button again, we get some more items added. The indicators have been grouped together and we've got some more indicators and controls. You can keep all this setup information in the code and send it directly as I have just done, or if you prefer, the same set of instructions can be saved to a file or created offline using any text editor of your choice. Setup files can be loaded in using these buttons here. Okay, now I'll run the main code loop and we can see what happens next. The code on the target board runs and sends regular messages to ConTest. The indicators are updating and I can see regular messages have been sent as the blue indicator above the start button is lit and the red indicator is moving left to right. I can use the bottom buttons on the board to increase and decrease the values on the bar graph and the red time graph over here. So this decreases the value. You can see both graphs going down, and the other button increases the values. We can use ConTest the other way too. The setup was programmed in ConTest to send messages to the board that you can recognize. This can be any message you choose. It is up to you. The switches send messages to control 3 LEDs on my board to switch them on and off. That controls LED 1, LED 2 and LED 3. Press again and they go off. Okay, the fourth LED on my board has its brightness controlled by the screen value I enter. 0 turns it off and 50 gives it full brightness. I can enter a value directly in here, such as 12, sets the brightness fairly dim, so a higher value like 42 will set a much brighter value. I can directly control the brightness with these two buttons here as well. If I keep pressing the down button, you can see it gradually going dimmer, and the up button makes it brighter. Okay, what I've effectively done is just sent a value to your code. How your code interprets that is completely up to you. So we can use ConTest to monitor outputs and internal states of our program, and also to control its behavior, all without writing a single line of PC code or knowing anything about how the PC works or having access to any PC compiler. You can use ConTest just to monitor what is going on in your code, or use it to create a full custom GUI as I've done here. For commercial developments, ConTest can be used as your user interface, and you are free to distribute your setup. Of course, your customers will need to obtain a license for their own PCs. Okay, I hope this has given you some idea of what can be achieved with just a few simple text commands, and I hope you find this program useful. Thanks for watching this video.